Sizewell B is Britain's first pressurised water reactor power station and the most modern in the world. The vast size of the plant with its massive dome belies the compactness of its core, which will provide enough energy to satisfy the electricity needs of 1.5 million people. The construction of Sizewell B has been one of the biggest civil engineering projects in this country, providing jobs for thousands of people and valuable contracts for many companies, both local and national, and from overseas. Over the last 3 years, and it nears its completion in 1994, the appearance of the site has changed significantly. "1991 was remembered by most people as the year of the big lifts. First off the ground were the turbine hall cranes, 4 massive beams, each weighing 130 tons and 65 meters in length. When coupled together, the cranes have the capacity to lift 320 tons. Their first task was to lift in the turbine house plant and equipment. Next to go were the 2 massive de-aerators. These remove air from the pure water returning to the steam generators from the turbines. A special crane, a Gottwald MK 1500, at that time the largest truck-mounted crane in the world, was brought to Sizewell in 71 lorry loads and took a week to assemble on site. The series of lifts it was to perform had been planned 9 years in advance. The reactor building's huge polar crane was the heaviest lift of the entire construction program and was lifted in 5 separate sections, each lift taking just 2 hours to complete. The polar crane is seated on a rail inside the reactor building and is able to turn a full circle. The trolley section situated between the 2 girders can travel their entire length. Thus, the crane can reach any part of the building. When Sizewell is operational, it'll be used for refueling operations and maintenance. Once the polar crane was in position, it was possible to lift on the huge steel liner of the reactor building's dome. This had been assembled on the ground in 3 sections, affectionately known as onion rings. Whilst the polar crane lifts had been the heaviest, the onion ring lifts were the bulkiest. This spectacular series of lifts were carried out over a period of 7 weeks. The first section went up on the last day of May 1991, with the final dome section being put in position on the 20th of July 1991, topping out the building. Several factors affected the crucial lifting program, not least of which was the weather. Because of the huge size and weight of the lifts, it was essential that wind speeds were below 12 miles per hour, and that they remained so for up to 6 hours at a time. Accurate weather prediction by the Norwich Weather Centre helped to ensure the success of the programme. Now that the reactor building had a roof, it was time to bring in its heart, the reactor pressure vessel, in which the nuclear reaction will take place. The vessel had been waiting in air-conditioned storage on site since its delivery by sea from its specialist French manufacturers. Made of steel and weighing over 400 tons, it is the most tested reactor pressure vessel in the world. 4 years of meticulous planning paid off, and the vessel was installed in only 2 days. This was the first major lift for the polar crane, which proved its ability, lowering its precious cargo with the greatest precision within the limited space of the reactor building refueling cavity. Following the reactor pressure vessel came the first of the 4 steam generators, the station's boilers. They will produce the steam that will drive the station's 2 turbine generators. At almost twice the length of the pressure vessel, the steam generators further tested both the skills of the lifting crews and the abilities of the polar crane. Now, almost 4 years into the project, Sizewell B was beginning to look less like a construction site and more like the model power station which its designers had so carefully planned. Compared to the exciting events which took place in 1991, the year to come may have seemed to the casual observer an altogether far more sedate period. The project entered 1992 on time and on budget, and it was important that the impetus be maintained in order to keep the project to its tight program. It was a year when construction completion allowed commissioning activity to increase. Inside the huge turbine hall, steady progress was made on the installation of the 2 625-megawatt turbines. The turbines will take steam from the 4 steam generators inside the reactor building and convert it into nearly 1,200 megawatts of electricity for the national grid. To step up the 23,500 volts produced by each turbine to the 400,000 required by the national grid, 2 transformers were installed outside the turbine hall. In July, 4 years of construction work culminated in the topping out of the 72-metre-high reactor building's primary containment, which involved the placing of nearly 100,000 tons of concrete. Inside the reactor building, there was a 6-month program to clean, flush out, and test the network of stainless steel piping comprising the reactor primary water circuit. Demineralized water, provided by the already commissioned water treatment plant, was pumped at high flow rates in order to remove any debris that may have accumulated in the system during manufacture or installation. Meanwhile, outside the reactor building, a concrete skin, or secondary containment layer, was being added. This is one of Sizewell B's multi-barrier safety features and in line with the defence in depth policy of the project. Seven meters beneath the base of the reactor, teams worked day and night in an elaborate threading and stressing operation. Vertical and horizontal tendons, some weighing as much as 12 tons and made up of 37 strands, were passed over and around the reactor building. Once threaded, the 11-centimeter diameter tendons were tensioned by jacks, compressing the entire building and adding still further to its immense strength. As Sizewell B entered 1993, the relentless pace continued.
Three, two, one, stop. Okay, so next scan is...
The reactor pressure vessel has been undergoing yet more tests, including a detailed pre-service fingerprinting inspection. Using ultrasound techniques enables every weld and critical feature of the vessel to be identified to give that vessel's unique characteristics. The data collated can then be used as the basis for regular inspections, which will be carried out throughout the life of the station. These pictures show the reactor building as it was in August 1993. The 4 steam generators are now insulated and covered in bright cladding. Pipes associated with the primary circuit's pressurizer are being welded. The operations centre of the plant, the main control room, continues to be the focus of attention for a large number of people, testing and checking every aspect of its control and safety systems.
Many of the controls here are active, particularly on the electrical systems. The others are in a state of being tested, and you can see a lot of the cables behind me, and some of the extra people that are working in here are to do with the testing of the controls, the data screens, the data inputs, and the interface to the computers. Eventually they will all go, and the control room will be manned by 2 people, a supervisor and a reactor operator.
Hello? Just the one. Yeah.
Where's Martin at, please?
Yeah. They just kept bringing up different fire alarms in different buildings, and they appear in whichever building. That's an overlay of the whole site, you see. And they appear in whichever building or sector it's in. It flashes up here.
What have you got on there? 20, 4 milliamp? And I get a reading of 20 yeah. Yeah. At the moment, none of the valves are connected. So we're simulating all these, but if I by instruments and switches and things. We're simulating an output from an I/O card. What this will do eventually is it'll turn a valve, operate an actuator on a valve.
They tell me the point. I confirm the description, the range of it. If there's any alarm settings, there is an alarm setting of 80 degrees rising on this. And then I can pick up the format. It automatically does it. I do a little bit of tracking, and I find the point. I highlight the point, and there is the reading there. It's the same as that. That is to a more precise reading, but that's what the operator will see when the station is running. And that's a good ambient reading at the moment. There's lots of teams out there doing temperature and all control circuits, loops and things like that to commission this power station.
Underneath the reactor pressure vessel, the network of stainless steel piping which makes up the primary circuit is undergoing tests.
Just about there, isn't it? Yeah, it's just pivoting on the buckle. Yeah, we're doing the ultrasonic inspection on the weld around this nozzle. Also the inner radii on the steam generators. The sound is emitted from the probe through the couplant medium into the steel, and then we get a reflector back, and it's recorded on the hardware downstairs.
Inside the building, the refueling machine is being put through its paces in preparation for the loading of fuel for the first time.
Okay, it's down, it's good. Right, now we need to bring it up to 79.25, less than 79.25. Okay, coming up. Right now we're raising fuel. That's shown here in the graphics. We're going to bring it out of the core about 2 feet. Move it to the next position, drop it down. What we're verifying is the fit of the dummy fuel assembly with the locating pins on the bottom core plate.
Three days later, the reactor cavity was filled with over 1,000 cubic meters of demineralized water, and the exercise was repeated to test the rig's capability under the water. Over the August bank holiday, there was a series of exercises to test the fit of the reactor pressure vessel head and the multi-stud tensioner, which is a large computerized spanner used to bolt the head onto the vessel itself.
To actually bring the tensioner into the building today in itself has required a lot of planning. Previous to that, obviously, the engineering speaks for itself. But yes, the actual logistics of bringing the tensioner in through the hatch and getting it across the building to the stand has meant a lot of work by a lot of people.
The hook of the crane is positioned in the centre, so it is lifted without any movement either way. And then we just take the weight by radio control, read to the crane driver.
With the lifts we're doing just now, the stage that the reactor's at, is a lot of precise lifting. The crane is designed to position any of these big lifts within a few millimetres up, down, out or in.
We've been preparing for the next key date in the project, which is cold hydro. And to do that, we have to have certain facilities in position. One was the multi-stud tensioner, which we put in yesterday. It's manufactured by a company called Worth, and their engineers were here to assist us doing that.
We closed the vessel head with this machine, with the MST. And we make this for a lot of 20 nuclear power stations from the world. It was all the time the same work for me and for another man from my workshop.
With it being a polar crane, it's very difficult. And then, as you can see, we've positioned it into its place, temporary place. And then what we do now is lower the crane off, to unwind the pin, which is a very difficult job because you can't really tell how much weight you've left on it because you've only got millimetre clearances, you see. And then when we get the pin out, we raise the crane, the hook, and then position the crane, hopefully, to lift the reactor head in.
Load should be coming off any time now.
Okay, keep going until the load's off at 18.
Tomorrow we'll be operating and bringing the MST down over the head to the bottom, to this mating flange, and setting these guides up.
think it's fair to say it's gone as smooth as any of the big lifts and has therefore been successful.
In the turbine hall, as elsewhere around the plant, routine tests and checks are being carried out daily.
We're inspecting the turbine hall cranes today. Everything which moves, in general, structure, gearbox, ropes, everything. Come back, John.
Come back, Tony.
Long travel south, please.
This year, Turbine 1 was successfully turned for the first time, and the hall itself is beginning to take on a finished look as it and the rest of the plant head towards successful completion.
Okay, we're in the rad waste control room, and this is the control desk for the waste storm manipulator crane. And what we're doing at the moment is we're going to position a drum which we've already collected and put this into the low-level waste tilt machine. First of all, what we need to do is input the specific coordinates of where we're going to, so we can send the crane there automatically. Once the coordinates are inputted into the computer, we get an automatic light up to which we need to press. On pressing this, the crane will now start on its motions in delivering this drum to where we wanted it to go. On the controls, we can actually follow the operation of the drum being delivered via a general viewing camera which we have mounted underneath the girders of the crane. And the drum will now be automatically deposited in an area called the low-level waste tilt machine.
Today marks an important landmark in the construction of Sizewell B. We're topping out the secondary containment building, which marks the end of the construction phase of what's been a wonderful project. To an engineer, I think this is something to be proud of, and will stand for a long time to show what the engineers of this decade can do.
What do you think it looks like from here?
It's absolutely wonderful. We're standing on top of a secondary dome, and inside that secondary dome is a primary dome, and inside that is the primary circuit, and inside that is the fuel-rich cladding. So there's a multiplicity of barriers, all of which would have to be breached if there was to be any problem for the public. And I don't think that's credible. I think that's absolutely impossible.
Can I ask you, first of all, today you're topping out the dome on the reactor building at Sizewell B. Your reaction to today?
Very proud of what we've achieved so far at Sizewell B. I think the contractors, John Lang, is the civil contractor, and all the rest of the contractors on my team have done a magnificent job in producing today. It's well ahead of programme, and I think it's a superb civil and mechanical construction job.
This is Kevin Bentley for Look East at the very top of Sizewell B's nuclear reactor building in Suffolk.
Standing on top of the dome here today, it's important to reflect on all the hard work that the team and the contractors have done to bring us to this stage.
Hi, my name's Ringo. I'm employed with John Lang Construction at Sizewell B Power Station.
Well, I'm Richard, bank with John Lang's, worked there 5 years.
My name's Thomas Sudden. I'm a scaffolder. Been down at Sizewell B Power Station for nearly 2 years, and I travel from Letchworth in Hertfordshire.
My name is Morris Bunn, and I work for Lone Manor Landscapes, I've been here now about 4 months.
I'm Mark Allen. I work for FB Taylor Cable Contractors, pulling cables. I've worked here for 2 years now, and I come from Ripon, North Yorkshire.
My name is Hilary Yates. I was born in Leiston, and I've been working here since 1988.
My name is Ron Lockwood. I've been here with Dubin Security for nearly 5 years, and I come from Carlton Coble near Leicester.
Hi, I'm Paddy. I drive for Davidson Sampson. This is a 360-degree machine.
Hi, I'm Carl. I'm a pipe fitter working for GEC at Sizewell B.
My name is Terry Reynolds. I'm a rigger working for GEC Elstrom. I'm working on the Sizewell B project. I've been working here for 3.5 years, and I live at Lowestoft. I commute every day.
I'm the leading firefighter on White Watch. I've been here for the past 5 years, and I live local in Leiston.
White Watch, Sizewell B Fire Team.
We are the A-Team. We are the A-Team. We're the best team.
I think this team deserves the chance to build another one of these stations, because I think it's very important that we're able to use this technology now that we've gone to so much trouble to develop it. I believe that this will go down as one of the best civil engineering projects that has been carried out for a very long time.